Hi everyone, welcome to the Solar and Storage Market Series. My name is Erez Dolev and I'm the Managing Director here at RENVU. Today we're going to be hearing from Tony Vernetti, a Senior Trainer at Enphase about Enphase System and Enphase Power Control. We also have with us today Kyle Peace, a Senior Engineer at RENVU, who he will share RENVU's advanced online quote generating tool and show how to create a completed quotes with full Enphase bill of materials in just a few minutes. But before we dive in and while we're waiting for more people to join, I'd like to give a little background on RENVU and some of the products and services we offer. RENVU is a US-based solar equipment distributor. We've been in the industry since 2012, and we currently have fulfillment facilities in California, New Jersey, and Texas. Our sales staff all have background within engineering and solar installation. A few products quickly to spotlight here. We carry the whole solar portfolio, HomeGrid and Fortress Power batteries, and can beat any price you see out there. We carry the Lumin smart panels. This is a great device to add to a solar and storage project since it allows you to use the existing main and sub panels and control the loads remotely during power outage or set rules for which loads will continue to work and which ones will be dropped. We have plenty of Hyperion 405 Black, 550, and 575 modules, which we are offering at as low as 15 cents per watt. I'll show you the price list in a second. We have the whole portfolio of Enphase IQ8 series and offering the IQ8, IQAM, and IQ8 Plus. Growup released their EV chargers, which are UL certified and have 50 amp output. And if you're looking for T-gaskets to make solar array watertight, Blicker has several options for different modules gap sizes. Email us at info@renvu.com if you have any questions about pricing or these products. Here's our bulk module price list for large volume options and our upcoming offerings of solar modules. We carry Zenshine, Canadian Solar, Hyundai, Hyperion, Telsun, Solar for America, REC, and more. All our brands are Bloomberg Tier 1. We are sharing in the chat a link to this page. We update it regularly so you can stay up to date with our latest deals for bulk orders. I'll take a minute also to mention the Blicker residential carport. This is a great way to extend existing solar systems or an alternative solution where you cannot install solar on a roof and when a customer is looking for more added values. Let me start a short version of the installation video while I'm presenting. This is a carport. The carport is designed to be assembled by a small crew. It doesn't require any specialized or heavy machinery to install. This is a solar structure, so it is eligible for the 30% ITC and possibly also the extra 10% for domestic sourced materials. It is modules and inverters agnostic, and it is designed and fabricated in the US and made from US sourced galvanized steel. It has a 25-year warranty. The structure is coming with a structural engineer P stamp. You can install up to 24 solar modules with 4 columns of 6 modules. A 2-car carport will generate 10 kilowatt power. You can use residential and commercial modules with it, with load capacities up to 48 pounds per square foot snow, 215 miles per hour wind load, and seismic design category F. We're sharing a link to the full version of this video in the chat, and we'll also add it to the follow-up email. Okay, now I'll hand it over to Kyle Peace to go over the online quote generating tool to show you how to generate a quote with the Enphase system in just a few minutes, and we'll get started with the webinar.
Thanks, Erez. All right. So here's our homepage, renvu.com. Our design tool here is one of my favorite things about our website. I work closely with our web development team in fine-tuning this tool. It's really a neat thing that I like to work with. So on our homepage, Before you get started, make sure you are logged in, or if you don't have an account yet, it just takes a few minutes to register. It'll be up in this top right corner, that register button. And we just need that so that we have an email address to send you the quote and a shipping address we can use to generate shipping costs. You'll find the design and quote tool here below the top banner. You can click anywhere on that image and it links over to the tool page. So there's 6 steps in the tool. On the start page, you can choose whether you want a full system, or if you already have solar panels or something, you could deselect those and just get the parts you're needing. Next page is the solar panels. Hyperion here is our most popular option, and they have great pricing right now, so I encourage you to check those out. And one of the nice things about this page, if you click through the options and give it a couple minutes for it to load here, you'll see the price pop up, and then you'll see the price per watt. So this is a cost density metric you can use to compare different modules and their relative pricing for your array. Note that this pricing is only for one module, and it's just for the my base account pricing I have here. So your pricing may vary, and once you add more modules, those go up in tiers, and the pricing will go down as well. But this just gives you an idea of where to start, what would be the most cost-effective option. The next page here, once you've selected your module, you choose your racking. There's options between pitched roof, flat roof, carport, and ground mount. Under each of these racking options, there's some sub options. For pitched roof, you can choose your roof surface type, such as comp shingle, Spanish tile, flat tiles, and metal roof. And then under flat roof, you have penetrating and ballasted. Same with the ground mount systems. And then carport is kind of a unique option. As Erez was showing, those blicker carports, you can actually get a quote for as many car spaces as you're needing joined together with the tandem system. So you can see cost for a full system with panels, microinverters, and that carport structure. Kind of a neat option there. I'm going to jump back to pitched roof with comp shingle because that's our most popular right now. And we'll do 2 rows of 14. You can choose between portrait and landscape. I like to use portrait whenever possible. It's just a lot more efficient for the number of roof penetrations for the array area, and minimizes the amount of racking materials you'll need. And then you get to choose your roof attachments. You can choose an iron ridge between the Flashfoot 2 and the Halo Ultra Grip. And then you can choose your rail color and your clamp color. I like to always make sure that matches the module aesthetic that you have. And then the rail duty rating, R10 or R100. And you'll get a little racking sketch here at the bottom as you make your selections to make sure it is as you intended. As you make your selections, you'll see the bill of materials add up here, and you get your total at the bottom. So you can get a cost per watt metric as you go along and make those selections. It's a good way to compare different options, such as if you want to use Enphase microinverters, but you also want to see, well, what's the cost difference with an optimizer? You can go ahead and select those and compare those different cost options. I'm going to show the Enphase here for a minute. Since we'll be presenting on this, you can choose between the plus M, A, and H models. It'll give you a DC to AC ratio there to give you an idea of the pairing between that module and the microinverter. It's always important, and you can add on energy storage with those 5P batteries if you like. We also added under string inverters recently, Fortress Power now has their, let's see, it's the eForce battery line as a new option. So check that out if you're interested as well. And then at the bottom, if you're choosing string inverters, you also can add on optimizers or rapid shutdown at the very bottom there. And then on the final page, once you've made your selections on the inverters, you can add on the numbers of spare panels you'd like. I highly recommend adding a couple. If you have a wayward Frisbee or a hailstorm or something, it can be a real pain for folks to find a drop-in replacement after several years have passed. The module dimensions and technology just keeps changing, and so that does make it a tricky task. You can also add on balance of system components, PV labels, a smart panel, an EV charger. Those are all options on that final page. And then you can see your bill of materials here. If you're not sure of any of these options, you could click on those. It would open a new page. You won't lose your spot, and you can read about the manufacturer documents. It's a neat way to learn as you go on making your selections here. Once you're satisfied, hit finish. You'll get to a final bill of materials. If that looks okay, you can hit generate a project, email me a quote, and you'll get an email with a PDF of this bill of materials and the pricing. And we'll also have it in our system, and we'll look it over proactively if we see any availability or configuration concerns, or if there's an upcoming promotion that you might want to take advantage of, we'll reach out to you and let you know. You can also email into any of the emails you get from us with your quote number and any changes you need if you weren't able to dial it in quite like you liked, and we can definitely help you out there. All right, so that was the solar design and quote tool. I'm going to go hand it over to Tony over at Enphase. Reminder, this webinar is being recorded, and we'll share a link once we have that ready. And then also, if you have any questions while we're going through this webinar, please share them in the Q&A section, and we'll get to those at the end. All right.
All right, thanks, Kyle. Share my screen here. All right, guys, can you confirm the correct screen is showing?
Looks great.
Okay, great. All right, thanks everybody for joining today, and thanks for having me, RENVU team. I always enjoy doing these sessions with you guys. Always have good attendance and great Q&A, and we're going to cover a lot of material today. So today we're going to do an overview of the Enphase energy system, the value proposition, and the key components of the system. And we're also going to focus on power control and how the latest iteration of Enphase Power Control makes it possible to do main panel upgrade, or makes it possible to avoid main panel upgrades in many cases without any impact to performance or energy production of the system. So I've got 3 basic learning objectives for today's session. After this session, you should be able to describe the key benefits of the IQ Battery 5P and Enphase energy system, explain how distributed inverter architecture improves system reliability, and lastly, explain how Enphase Power Control allows you to avoid expensive main panel upgrades. So first, let's do an overview of the key value proposition of Enphase and distributed architecture. A good analogy for different solar inverter technology is a multi-lane road that's packed with cars like you see in these little pictures here. If all those cars are forced to merge into one lane and it's blocked, then traffic comes to a standstill. Compare that to a multi-lane road which doesn't merge. All lanes flow independently. And if one happens to be blocked, the rest of the lanes remain open. Now, if you were in a hurry to get to an important meeting, which road would you take? A string inverter system is like the multi-lane road that merges into one lane. Since all the solar panels are connected into a single inverter, if it fails, then solar energy production is going to, of course, grind to a halt. A microinverter-based system is like the multi-lane road where traffic keeps flowing even if one of the lanes is blocked. Each solar panel and microinverter pair work like little individual power plants. So in the rare instance that one stops working, the rest are going to continue to produce power, and the homeowner, of course, is going to continue to save money. Many new solar system designs with batteries on the market today use a hybrid inverter. A hybrid inverter converts power from both the solar panels and the battery, so one inverter serves both. This may sound efficient. However, if that hybrid inverter does fail, and their life expectancies are much shorter than solar panels, the consequences are even worse compared to solar alone. The entire system, both solar production and the battery, is going to stop working. The impact of the homeowner is much greater. No solar production obviously means no savings. No battery means no peak rate savings. No export to the grid for credits where that applies, like in California. And of course, no backup power. How many customer referrals are you going to get if a customer has a power outage due to an inverter failure and it takes them weeks and weeks to get that inverter fixed and the system up and running again? So let's do a review of all of the Enphase energy system components. If you've been working with Enphase for a while, you know that there are many different configurations you can choose from with Enphase, from backup power systems to grid-tied batteries that don't do backup but do save money, or solar only, and so forth. So in this image, we have kind of like the Cadillac that has all the bells and whistles possible with an Enphase energy system. This is a complete battery backup system with the Enphase IQ EV charger as well. So high reliability and high performance features of the Enphase system are a result of all major components of the system designed from the ground up to work together. So pictured here, we have the key major components of a complete backup power system. We've got IQ8 microinverters, which of course convert DC power to AC power from the solar panels to the home and the grid. The IQ Battery 5P provides backup power and potentially additional bill savings depending on the rate structure. The IQ System Controller senses grid outages and it disconnects when needed to provide backup power. The system controller isn't required if it's a grid-tied battery without backup power. The IQ EV charger is pictured there in the garage, way in the background, is of course available for EV owners, and it's one of its benefits is that it can charge cars only with excess solar energy because the Enphase system is monitoring consumption and solar production. So it can actually control the power output of the EV charger so it only charges with excess solar, which is not only the most environmentally friendly thing to do, but can actually save homeowners a lot of money as well. The IQ Combiner is named that because it combines the solar circuits into one box. It also houses the IQ Gateway for control and monitoring of the system. And that leads me to the last benefit that I can think of, which is the entire system can be monitored with a single app, the Enphase app, from EV charging to battery state of charge and performance and solar. Everything is in one place. The IQ8 series microinverter is the key component of the Enphase energy system. It not only maximizes energy production, it's also critical for our backup power systems because it has what we call grid forming capability. There are 5 models of the IQ8 series microinverters with different power ratings, as Kyle pointed out, so it makes it easy to find the perfect pairing for their solar module of choice. The highest power model we have is the IQ8HC, which is suitable for modules up to around 530 watts. They have an industry-leading 25-year limited warranty, whereas string inverters typically have only a 10 or 12-year warranty. We offer this long warranty because of the rigorous process that we use for design, testing, and manufacturing of our products. For example, we put thousands of individual microinverter units through a total of 1 million cumulative hours of accelerated lifecycle testing before releasing a new model. Our microinverters have no moving parts. As you're probably familiar with, sometimes in mechanical systems, the thing that causes a failure is a moving part, like a fan or a pump or something like that. We've eliminated those items from our inverters for reliability reasons. The system is designed to be basically plug and play, with one microinverter plugged into one solar module and then into the Enphase Q cable, which runs down to the combiner and main panel. It's an AC circuit, just like the rest of the wiring of the home, so any qualified electrician can easily install an Enphase system. They don't have to have special training in direct current. So here we have sort of the crown jewel of the Enphase energy system, the IQ Battery 5P. The 5P is by far our most powerful battery yet in terms of how much power you have per unit of storage capacity per kilowatt hour. The 5P is an ideal battery when it comes to starting challenging loads off grid, like air conditioning systems or pumps. The 5 in the 5P represents a 5 kilowatt hour energy capacity. The 5P can be used either for a grid tied configuration where it's just there to save money by offsetting peak energy consumption. Can also be used, of course, for backup power systems like I mentioned. We use the safest battery chemistry available today, which is lithium iron phosphate. It's much less susceptible to thermal runaway. And we have the UL 9540A battery safety certification to prove that. The power output is here at 3.84 kilowatts. I want to remind you that that is for a single unit, and most systems are going to have 2 or 3 or 4 of these units to achieve the right storage capacity for that homeowner. Because it's an AC coupled system, every time you add another battery, that adds on to the power output as well as the energy capacity. So I'll go through some examples here in a minute. Our batteries have a 15-year limited warranty. There's no dangerous high voltage direct current in our batteries. And just like with our individual microinverters, there's no moving parts or fans in the battery system either. It's designed to be much more field serviceable than our previous generation as well. So in the rare chance that there is an issue with the microinverter or even with one of the circuit boards inside the battery, it can be serviced on site without having to ship the battery back to Enphase. So let's dig into the power a little bit more here. So on the first 2 columns here are actually both Enphase 5P battery systems. I wanted to compare a single 5P, which is the far left, to your average system out there, which is around 3 5Ps or 15 kilowatt hours. And then I'm doing a little comparison here to some of the other offerings on the market. So 3 of the IQ Battery 5Ps will have a total storage of 15 kilowatt hours. The total continuous power is 11.5 kilowatts, and the peak power for up to 3 seconds is 23 kilowatts. So again, a ton of power there to be able to start up and run large appliances. And if you note in small print below that, it says power start capability 144 amps LRA. LRA is locked rotor amps. That's a spec that you'll always see on HVAC compressors because they demand a lot of power for a fraction of a second when they first start. And that is called locked rotor amps. So this is indicating that 3 of these batteries can start an air conditioning system, for example, that has locked rotor amps up to 144 amps. That's pretty typical for about a 5-ton, relatively aged, not the newest technology air conditioner. So even just 3 of our 5P batteries can start a 5-ton AC even without a soft starter in the system. The Powerwall 3, just to kind of give you a sense of the comparison of power, has a very similar continuous power rating of 11.5 kilowatts compared to, again, the Enphase 3 of the 5Ps at 11.52. And the peak power rating is not stated on their spec sheet, but they do have locked rotor amps also mentioned on their spec sheet, which is very similar. I think it's about 148 locked rotor amps. So in terms of power and performance and starting capability, 3 of the 5Ps is very similar to the Powerwall 3. And then to the right, we've got the Franklin Home Power at 13.6 kilowatt hours, so about the same capacity, but its continuous and peak power is much, much lower. And the same as you can see with SolarEdge Energy Bank. So one of the questions that needs to be answered during the initial kind of design and sizing of the system is, what's the minimum size battery I need in order to run certain loads in my home? And you can determine that actually by looking at the breaker for that load. And I've got a few examples here to kind of make this a little simpler. On the far left, we've got a single 5P unit, 5 kilowatt hours. A single 5P can start basically anything that plugs into a standard 120 volt outlet, including little window mounted air conditioners, for example. Any small kitchen appliance like a microwave or refrigerator even, garage door can all run off a single 5P. Now, 5 kilowatt hours is a little small in terms of the energy storage for most homeowners. So again, this would be like a very minimal starter system for someone who is comfortable with having a limited amount of energy storage there. Most homeowners are going to go with 10 kilowatt hours or larger. So if you have 2 5Ps, that's the second one here, 10 kilowatt hours, that can start pretty much anything that is connected to a 40 amp 2-pole breaker in that backup panel. And of course, any 120 volt loads as well. An example of a very typical load that would be on a 40 amp breaker would be a 3-ton air conditioner. Now, if you've got a 60 amp breaker, say for a 5-ton air conditioner, that customer would need 15 kilowatt hours, or 3 of the 5 Ps. Now, if the customer has multiple large electrical appliances and some of those have to run simultaneously, that means they're drawing power at the same time. That's when you're looking at designing systems that are 20 kilowatt hours or larger, so that that battery is going to have enough continuous power to be able to run those multiple large loads simultaneously. Our system has 2 options for the IQ System Controller 3. Those are the 3 or the 3G. This is more for designers, but it's important. It's kind of a nice thing for salespeople to know, because they have different limitations in terms of how much energy storage can be connected to each one. Just to review, the main function of the IQ System Controller is being a microgrid interconnect device. So it senses grid voltage, and if there's a grid outage, it automatically and instantly disconnects from the grid and signals the microinverters and the solar array and the battery to basically form that microgrid and provide backup power. It uses high-speed wired communication compared to the previous generation, which used a wireless protocol. So with the wired communication between components is much snappier and more reliable, and updates are a lot quicker to do as well. So here we have the 2 different systems. The first one, the IQ System Controller 3, is ideal for allowing for maximum energy storage, battery storage on our system. The IQ System Controller 3 can have up to 80 kilowatt hours of capacity, which would be a total of 16 of the IQ Battery 5Ps. Now, it's important to note that the Controller 3 does not support the integration of a generator directly into the Enphase system. If you have a customer that wants to get a generator in the future, or they already have a generator and they're planning on having that integrated into their Enphase system, then you would have to get the IQ System Controller 3G. Now, the 3G can accommodate a pretty substantial battery system, but it's not as big as the Controller 3. The limit with the Controller 3G is 40 kilowatt hours of battery storage. And that's basically because one of the inputs in the controller for power input is dedicated to the generator, and it can't be used for for battery storage. And while we're on that note, let me just review the value of a generator with Enphase. With Enphase, a generator can actually be connected directly into the system controller, like I said, and it can operate simultaneously with solar and storage. In almost every other configuration out there that says that they're generator compatible, the way it works is the generator is on an automatic transfer switch, and if the battery system runs out of power, runs out of energy, that system can switch over to the generator. So basically the battery turns off, the generator turns on. With the Enphase system, the generator can operate together with the Enphase system, which allows the generator to be used to potentially recharge the battery if they've got cloudy weather for a couple of days. It can also be there just to supply additional power. If the homeowner has, say, kind of a small battery and they want to run a couple large appliances, they can have their generator basically support and add more power input so that they can run more appliances and have more power. So as we mentioned, we've got several different configurations. I'm just going to go over the two most popular two most popular battery configurations, which are a grid-tied battery for non-backup. These are especially popular in California right now because of the net billing tariff, the current iteration of net metering, basically, where it's not called net metering anymore because it's technically not that. And there is very little value to exporting solar power back to the grid during the middle of the day when there's excess solar. So a battery is really key here for storing up that energy during the daytime, and then using that energy during the peak period in the evening to avoid paying peak rates to the utility. And there's an additional little bonus with the net billing tariff, which is in a couple months of the year, August and September, you can actually export the energy from the battery back to the utility grid, and you can get credits at a very high rate for a limited period of time and basically build up those credits and use those credits toward future costs. And of course, we have our battery backup system. Pictured here is a typical whole home backup where you've got the main panel that's supplied by the system controller 3 or 3G. And you've got your IQ8 PV system on the solar array connected into the IQ combiner, and an IQ battery 5, as many as are needed for this particular customer. Actually, mention one more thing. I'm just going to go back to the grid-tied system, important little detail here, which simplifies the installation. As you can note from this diagram, there's no system controller. As I mentioned a couple of times, that's only needed for backup power. So that since this is a grid-tied battery with no backup power, the battery can actually be connected to the IQ combiner if there's sufficient space in there. So say if somebody has 2 branch circuits for PV, they can use the other 2 circuits for batteries in that combiner. And then that means there's only one connection, one breaker that's going to be used in the main panel of that homeowner for connecting the IQ combiner. So if there's limited space in that service panel, this is kind of a nice little feature. Also simplifies the installation. And I just want to do a quick review of some of the additional benefits and differentiators of the Enphase system. We offer what are called IQ load controllers. 2 load controllers can be installed on any Enphase system, and they can be utilized to basically automatically disconnect certain large loads when the system goes into backup operation. Say there might be some loads that are potentially problematic in terms of how much power they demand, potentially have the potential to collapse the microgrid. You can set those up to automatically disconnect. You can also program this feature so that if the battery gets down to a certain state of charge, say 20% or 30%, whatever you enter, then those LEDs will be shed once it reaches that percentage. We also offer power start technology. This is by default how the battery works. When I was talking about the locked rotor amps startup capability of our system, this is what it's all about. So it's not just the peak power of the microinverter. Power start actually is made possible by the super fast microprocessors in our system. If there's a load that's demanding a very high amount of power, it is able to react. All the microinverters in the system can react almost like a choir of singers and make a quick adjustment to the voltage of that microgrid. It lowers the voltage very quickly and temporarily in order to allow that appliance to start, and then it'll immediately ramp that voltage back up. And that basically gives it an extra effective boost of power to start motor-driven appliances. No ratio sizing restrictions. So when using IQ8 microinverters on the solar array, you can install a very large solar array even with a small battery. With the previous generation of solar microinverters, the IQ7, and with other competitors on the market out there, you have to be really careful when sizing the solar array compared to the battery size. If you've got too much solar, it can be an unstable microgrid. So again, with the IQ8s, we've eliminated that problem. You can have as much solar as can fit into an Enphase system controller with any size battery. Generator support I already talked about. StormGuard is, I'm sure, a familiar feature for any of you who have been selling batteries. StormGuard basically monitors alerts from the National Weather Service and will switch the battery from either savings or self-consumption over to full backup automatically for that homeowner. That'll get that battery fully charged in preparation for that power outage or storm coming. And once the threat of that power outage is gone, it'll automatically switch back to the previous mode, whatever it was in. And we also have Sunlight Jumpstart. I'm just going to skip that one for now because I've got a couple of slides that go into that, which are right here. Enphase offers superior resilience with Sunlight Jumpstart. So in order to, the best way I've found to explain Sunlight Jumpstart is to talk about the shortcomings of a typical AC coupled system. By that, I mean a non-Enphase system. So with a typical AC coupled system, when that battery gets down to a low state of charge, let's say that there's a grid outage and solar isn't producing much power since the panels are covered with snow during a snowstorm. Think Texas in 2020. The battery is powering the home's loads, and the state of charge drops, eventually gets down to 10%. the battery enters the standby state and the home's power will go out. Now, this happens because in typical AC coupled systems, the solar inverters need the battery to be there to form the microgrid. That allows them to turn on and start converting power. The system doesn't know when solar power is going to be available today, when the sun's going to come out again. So it needs to keep some energy in reserve so it's able to try to start solar the next day. During the day, the battery is going to keep powering up and seeing if the solar system is actually working. Every time it does that, it consumes energy rather. Eventually, it's going to drop down to 2%, which is an extremely low state of charge. And the battery is basically going to stay off at that point until the utility grid is back up again. Now, if this happens to a homeowner during like the first day of a 10-day power outage, like I'm sure some people in Florida and North Carolina are experiencing right now, they are going to be without power for that entire 10-day period until the grid comes back up again. That's going to be awfully disappointing if they spent $30,000 or $40,000 on a robust battery system. So now let's compare that to the Enphase energy system with Sunlight Jumpstart. If the battery state of charge does get down to 2%, the battery is going to shut off just like any other AC coupled system. However, because the IQ8 microinverters on the solar array can start the microgrid and begin converting power without the battery, once the sun comes out, the IQ8s basically allow a system that has a critically low battery to automatically recover without the help of the battery itself. Solar is going to recharge the battery, and that customer is going to get their system fully operational again. And so in summary, the Sunlight Jumpstart is going to provide a much superior level of resilience compared to typical AC coupled systems during prolonged power outages. I wanted to touch briefly on system expansion for those of you that work in California. In California, as I mentioned early last year, everyone, net metering changed to the net billing tariff. So there was a big rush of people to get systems installed under NEM 2.0, the predecessor, because it was a much better deal and they could be grandfathered for 20 years. Now, the challenge for those customers is that if they want to increase capacity on their system, they want to add more solar panels, they're limited only to 1 kilowatt, just a couple of solar panels, or else they're going to be shifted over to the net billing tariff. That's obviously not what those homeowners want. So we have a way, and these are approved configurations by the utilities in California, to install an additional system with Enphase components that can help provide more solar power, and it's configured in such a way that the expansion system, the new system, is monitoring the actual consumption of the home and is allowed to produce as much power as the home is consuming. The expansion system doesn't have the ability, or the permission, to export energy back to the utility grid. So essentially, the original system, or the legacy system, if you will continue to always produce its maximum amount of power, and it can export all that back to the utility grid. And the expansion system is allowed to produce as much power as the home is consuming. So they can work kind of in tandem to cover the consumption of the home and feed back any excess energy from the legacy system under the NEM 2.0 tariff agreement for maximum savings for that homeowner. So this is a great solution for customers that have had their systems installed for several years, and their energy consumption of the home has increased. So now their old system is not really sufficient anymore, and they've got a big true-up bill. They can add this more capacity to their system and help reduce that true-up bill. All right, so now I wanted to get to the special topic that we mentioned, which is Enphase Power Control. Just want to make sure, checking my clock here, make sure we have enough time for a Q&A at the end here. So Enphase Power Control basically controls the power produced and exported by an Enphase energy system. And one of the key benefits is to avoid expensive main panel upgrades. It also allows us to install more PV than would normally be allowed by the main panel. It's used when we want to add all the way up to 80 kilowatt hours of battery capacity to our system controller. Can also avoid utility transformer upgrades. It's used to enable export mode for IQ batteries. Again, this is for those Californians that want to be able to export battery energy back to the grid. PCS also applies for that. And therefore maximize savings for those homeowners by exporting stored energy. And PCS is available for these system configurations: solar-only systems with IQ8 series micros, and both grid-tied and backup systems with either the IQ Battery 5P or the previous generation 3T and 10T. So before I talk about the new version of PCS for main panel upgrade avoidance, similar to before, I found the best way to explain it is to talk about how we currently do it and how the upcoming version, which is literally coming out next week, released on ITK for all installers to be able to use, and how that new iteration works. So the current implementation is based on the 120% rule. According to this rule, in this example with a 100 amp panel, the backfeed breaker can be 20 amps at a maximum. So with 80% loading, the maximum current allowed is 16 amps, which is about a 5 kilowatt PV system. It's a smaller system than most homeowners need these days. With PCS implemented, the Enphase system can control the output of solar and battery so it never exceeds 16 amps. This means that you can install more solar capacity. In this example, we have a 6.2 kilowatt PV system, which has a 20 amp rating. Most of the time, this isn't an issue, as the solar PV system is usually producing well under 20 amps. This feature can be applied to a solar-only system or a solar system with batteries. This works pretty well for systems that have batteries and solar, because the batteries and solar are rarely actually backfeeding the main panel simultaneously. During times of high solar production, the battery is normally being charged by solar. So the electrical current from solar isn't backfeeding to the main panel. It's going through the combiner into the battery. Now that brings me to the downside, or the Achilles heel of this current implementation, is that during times of high solar power output, such as midday in the summer, the power output might be curtailed, and the system would produce less energy than it potentially could. This effect is a lot more pronounced with solar-only systems, since solar is backfeeding the main panel at all times. So another example of the downside of this approach. If we increase the system size further so its potential output is well above the backfeed limit, the energy production is going to be significantly lower than without PCS. So in this example, the PV system is rated at 24 amps, but PCS limits the backfeed to 16 amps. So during times of high irradiance and production, the current or power of the PV system could be significantly curtailed or reduced. Now let's say the system is in California with a net billing tariff, and the customer wants to have two 5P batteries to sell energy back to the grid. Those two batteries have an output of 32 amps. And again, the PCS limit here is 16 amps. That means the batteries aren't going to be able to discharge back to the grid at their maximum speed during that high value period. So the customer is not going to save as much money as they potentially could with this limitation. So that being said, what I'm presenting now is the upcoming iteration of PCS, which is significantly improved. And this says September 2024. It's actually next week that it's coming out. So this is a little bit outdated. So we're calling this Busbar PCS. And in this example, we have a 100 amp main panel again. The 120% rule says the max backfeed breaker is 20 amps, which again is 16 amps continuous current, and only about a 5 kilowatt PV system, smaller than what most people need. So Busbar PCS uses measurements of electrical current from the PV system and from the grid with consumption CTs, and will allow as much as 64 amps of backfeed current from the PV system. Now, 64 amps is a very large PV system of around 20 kilowatts DC. Now, in this scenario, the only time the power output would be curtailed is if the home's electrical loads were drawing so much current that the main breaker would trip. In other words, it would be extremely rare and probably never happen that the system would be curtailed. So again, just to be clear, we're talking about adding or installing up to a 20 kilowatt DC system, PV system on a 100 amp panel with power control system and without having any impact on energy production of that PV system. It's quite remarkable. Now let's take a look at an example of Busbar PCS on a system with backup capabilities. The system has an IQ system controller, so it can disconnect from the grid and provide backup power. So in this example, now we have a 200 amp service and 200 amp main panel, bus, and breaker. With today's version of PCS, the backfeed limit would be 32 amps on a typical 200 amp panel. So this example with an 11.5 kilowatt PV system wouldn't be able to produce its max power at all times. With Busbar PCS, the PCS limit can now be as high as 128 amps. This large PV system would likely never be curtailed, as I mentioned before. And here we've got 3 of the IQ Battery 5Ps. They would also be able to output their max current of 48 amps without any issue. So to make it really crystal clear, the differences between the current version and the upcoming version, I've got them side by side here. So we say with the new version of PCS, you can have up to 4 times more power from an Enphase system. So here we have an example again with a 100 amp panel. On the left, we have the 120% rule, where there's a hard limit of 16 amps of backfeed current. In this example, the PV system is a little bit oversized at 7.5 kilowatts DC, which is rated at 24 amps. So basically on a sunny summer day, you've got high irradiance and the power output of this PV system would likely get clipped or curtailed, and the homeowner is going to miss out on potential savings. With Busbar PCS, which is on the right here, the backfeed current can be as high as 64 amps. So the PV system can be 4 times, or I should say the power output of the power backfeed from the solar back to the main panel can be 4 times higher with Busbar PCS. And lastly, we've got a comparison of solar and batteries on a 100 amp main panel. So with the current version of PCS, the limit again is 16 amps for a 100 amp panel. So this 7.5 kilowatt PV system would get clipped. And the battery, which is rated at 32 amps, wouldn't be able to output its full power. It would be basically half its potential power. So customers like those in California wouldn't get the full potential savings. With Busbar PCS, the customer can have a 20 kilowatt PV system and a 20 kilowatt hour battery with 4 of the IQ Battery 5Ps and still be able to get the full power from both PV and the battery system. And one last example here. So this is a solar only system installed on a 200 amp main panel. With a 120% rule, there's a limit of 32 amps of backfeed current. With Busbar PCS on this 200 amp panel, the backfeed current can be as high as 128 amps, which is of course a massive PV system. So the point here is a lot more flexibility. You can install much larger PV and battery systems using Busbar PCS and avoid main panel upgrades in many cases. And the big benefit with Busbar PCS is that it's not going to curtail the system, and that customer's not going to see a kind of any limitation or a reduction of the energy production of that PV system. And they're going to get the full power available from their battery system as well. All right, so with that, I am ready to to go to the Q&A session here. This is always fun. So if you guys would like to, if there were any questions that were typed in, let's take a look at those and take any additional questions people have.
Great. Cool. Thanks, Tony. Yeah, so I see that we have only one question for now from Ben. So if anybody else have questions, throw them into the Q&A. There is a link or icon at the bottom of your page with a question mark. That's where you want to those. Okay, so Ben is asking, I have two systems, one on M250, the old version of Enphase microinverters, and another with IQ 7 pluses. I'd like to get off-grid permanently. Do you have an architecture that supports off-grid installation without the grid? Would that be backward compatible to previous microinverter installations?
That's a great question. I have to admit, I'm not super up to speed on Enphase's full off-grid configuration. It is something that I know that we support now that we didn't support in the past. I think the best thing for me to do is actually to share a recorded webinar on the topic of off-grid systems with Enphase with this person and connect them with our off-grid expert at Enphase if they'd like to get some assistance with perhaps a preliminary design or get some questions answered.
Sounds good. Yeah, so we can add it to our follow-up email with everybody, so you can watch that specific webinar about off-grid. And always you can install a AC coupled inverter. So instead of doing a DC coupled situation, you're just adding off-grid inverter if you don't want to use the existing Enphase solution for complete off-grid. Kyle is asking, can you clarify that there is an additional CT required to be installed on the line side of the MSP? This is related to systems that have been recently installed that may benefit.
So, Kyle, are you asking, is this regarding power control? I'm just assuming that because that's when the additional CT would be required, or with expansion systems as well.
He's saying yes.
Okay, so here I've got the diagram up of, sorry, let's go to Busbar PCS with storage. Okay, so there are 3 CTs needed for PCS, and they all come with the Combiner 5. Those are 2 consumption CTs on the main feeders to the main panel, production CT, which is inside the IQ Combiner 5, and a battery CT, which is included with the combiner and has to be installed on L2 of all of the batteries in the system. With those 3 measurements, we can do any of the versions of PCS that we mentioned.
Was it included also in the IQ Combiner 4? I assume that this is what they probably installed before the
Combiner 4 would not include the battery CT.
Okay.
So that would have to be purchased separately. Battery CT isn't required for just a regular battery backup system without using PCS. But if PCS is being used, then and now that I say that out loud, I think I'm getting that wrong. Yeah, forgive me for a moment there for that slip up. The battery CT is going to always be required with any battery system. Where there is the need for an additional CT is with expansion systems as well. This might have been what Kyle was asking about as well. With expansion systems, we have to install an additional set of CTs to monitor the existing or the legacy PV system. So that's pictured here on the top here. So that's the only interface that we have with the legacy system. We don't have any means of controlling or stopping power production of the legacy system, but we do require the installation of CT so we can monitor how much power is being produced at that moment and compare that to the consumption CTs. And that determines basically how much power the new system is able to produce without exporting to the grid.
And
So
he has a follow-up question about the combiner 5. He's saying, perfect. So this adjustment can happen virtually with any IQ combiner 5 or 5C install.
yeah. And I do want to just mention one important thing that I forgot to mention earlier, which is that for Busbar PCS, it's important that the consumption CTs are installed on the main feeders to that main panel. Now, there are instances where that's not possible or it's very difficult. Just physically, there might not be any space, or the way that the wires come into the main panel, it's just not physically possible to put the CTs on the main feeders. In those cases, we can't use Busbar PCS. It really needs to be an accurate measurement of the total amount of current flowing through the main panel. A workaround that, I'm not talking about PCS, but with regular battery installations with consumption CTs installed, a workaround that can be used if PCS isn't used is bundling all line ones together and going through one CT, and bundling all the line twos for the loads I'm talking about, bundling all line twos together through the other CT. That way you can capture all the loads. That is not a reliable enough method according to our engineers, for Busbar PCS, because of the chance that there might be mistakes made. All the bundling might not be done correctly. Maybe not all loads that are in the panel are actually bundled. So for that reason, just to reiterate, with Busbar PCS, you really do have to install the consumption CTs on the main feeders going into the panel there.
And another question here from Team Soto. When stacking batteries, do you run them in parallel or daisy chain?
Oh man, I'm not, I don't have the kind of that level of knowledge of system design, but the way that they appear to be daisy chain, but I think when you're talking in terms of electrically, how they're supplying power into the controller, they are in parallel. So, if you've got five 5P batteries on a system, they can be connected side by side, and one set of wires goes through and connects all those 5P. You don't have to have like 5 sets of conduit, coming out and going into the system controller. You just have all those batteries interconnected with very short conduit pieces, and the wiring just runs through those conduits across those the 5 batteries in that example.
Robert is asking, can the average homeowner program this system or make changes without the help of the installer?
Well, the main changes that a homeowner would make would be changing the system profile, depending on how they want to use their battery. They can also change some other things like the reserve capacity, which is if they're using the battery in savings mode, and the reserve capacity is 30%, it'll utilize the battery until it gets down to 30% and then stop using the battery for saving in order to retain some capacity for backup power. The 3 operating modes are savings mode, self-consumption, and backup power. Customers, if they know that a storm is coming, or say they live in areas that are hit by hurricanes, they may want to put their system in backup mode for 3 or 4 months of the year when storms and power outages are more likely to happen, and the rest of the year leave it in savings mode. So homeowners do have the option of changing that profile. There are other things that homeowners can do in the homeowner app, but those are in my mind, the most important feature that they have access to. In terms of changing settings, like for PCS and some of the more technical issues, really do require an installer with training on the Enphase system to set those features up. And some of those things they cannot be changed by the homeowner.
Great. We went through all the questions that came in. I think that we can close the webinar. Thanks, Tony and Kyle, for co-hosting this webinar with me today. Thank you, everybody, for participating. Our team will work on the recording and send a follow-up email with the recordings and more information about everything we discussed today in the following day or two. Have a great rest of your week, everybody. Thanks, Tony.
Bye, everybody. Thank you.